Hey, my name is Andrew McLaren. Today I'm going to be showing you the easiest way to do the right hand rule. I've done a lot of tutoring. This can be a thing that can be really tricky for students because they're trying to do this trick with the hand without really understanding what these vectors are. And the easiest way to do this is to look at your coordinate plane with positive x, y, and z. And I know if I have my paper on my table that like positive x, positive y means that z is kind of coming out of the table towards me, and negative z is going into the table like downwards. So that's really important to know that you've got like your positive z up there. So you've got that positive z and negative z there when you look at this from that perspective. So your right hand rule is basically giving you a z when you multiply the x and y. And so you can see when you have a positive x and then a positive y, you get a positive z value. And I like to visualize this with torque because that's just the easiest for me because I can visualize torque as a positive or negative value. And so I can see this wheel spinning, what is that? Counterclockwise, right? So this wheel's spinning counterclockwise because this force that's being applied at that distance there. So I can see that spin and how that works. Now, if we have like a smaller force, you get less torque, doesn't spin as much, right? So you can kind of think about that. But where this really comes in useful is when you start looking at the negative. So if we have like a negative force, so if you're like in a positive radius direction, and you've got a negative force, that's going to give you negative torque. So this will make it spin the opposite way than we were just talking, right? So you can kind of see that. And then if you have a negative force and a negative radius, it's kind of like negative x values and negative y values, right? And that's going to actually give you a positive spin. So like pushing this right here is also going to make it spin counterclockwise, just like pushing that way would make it spin counterclockwise. So they have the same torque. So that's kind of what's going on. And you can then, now knowing that, think about this right hand rule. And so your right hand is basically some x, y, and z axes. So what I like to think about is like, okay, so I've got my hand here, right? And for me, the right hand rule I usually do is this is my x, and then this is my y, and then my thumb is my z. So I can see like positive x, positive y gives me a positive z for me, because this would be positive x for me, positive y for me, and then positive z would be up. So you can kind of see that with that rule. There's also this one with like the fingers. It's the same sort of thing. It's your positive x and positive y give you a positive z. So I think A is your x, B is your y, and then this would be your z, which goes up, given those arrangements. And then with the curl, it's the same thing. It's like your thumb is the z product, and then you basically have a positive x with your palm, and then your fingers curling around is the positive y. So that's kind of how that works. So you can imagine like, okay, I've got my hand, I've got my maybe my negative x, my negative force, right? And so that's going to be positive as well. But if I have like a negative x and a positive y, then my z is negative. And then so I can be like positive x, positive y, positive z, positive x. Kind of weird, but negative y gives me a negative z. Something like that. So that's the right hand rule. Let me know if you need any help.